Hey guys, welcome back. So we are going to continue day 12 right now with electron configuration, but I needed to add the periodic table. And so what we have here, and we're going to start the highlighter, we have right here in blue, we're going to highlight this in blue. Same with this one, because this one is special too. And these are the S. So all this is S. That's your S block. This is also S right there. And then, highlight purple. P. There's P. All right. D. All right, so we had the, S, P, D, and then F. And so we got F. And then the other thing is N here, right? 1, 2, 3, 4, 5, 6, 7. Now, there is a curveball coming with the D's and F's. And some of you guys know this. Some of you don't know this. That's okay. But the D's are off by 1 and the F's are off by 2. We'll talk about that. And so when we look at this, we got our electron configuration and our orbital notation going to come up. And so we're going to come down here. Hydrogen is N equals 1. L, it's an S orbital, right? Because we're 1 S. So we're N equals 1, S block, 1 electron. So there's 1 electron in the 1s. So that means in the first orbital, we just have the arrow there. Boom. And that is hydrogen's electron configuration and orbital notation. It's that simple. All right. Helium. If we look back at helium here, we're still N equals 1, 1s1, 1s2. So helium has 1 S2, and it has an up and a down. All right. Now, I have one box drawn for 1 S, and that's it. Well, if you remember, we did the orbitals. N equals 1, L is 0, M sub L is 0. I only have one orbital. All right. I only have one orbital. So you could technically put helium right here. All right. And so this is one box, one orbital, 2 electrons. If you notice, the P's were L equals 1. And so M sub L is negative 1, 0, 1. You have 3 orbitals, 6 electrons. So you have 1, 2, 3, 4, 5, 6 boxes, or 1, 2, like 3 orbitals. The D, L is 2. So M sub L is negative 2, negative 1, 0, 1, and 2. There's 5 orbitals, which is 10 electrons, 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And F has 14, and there's 14 across there. So how many boxes? It's the number of elements divided by 2, if you want to memorize it that way, right? However you want to remember how many boxes, but S's have 1, P's have 3, D's have 5, and F's have 7. All right, so lithium. Going back to lithium. Right here, 1s, 1, 2, and now we're in 2s1. And so we have 1s2, and then 2s1. Right? 3 electrons, right? So my total electrons is 3. Lithium should have 3. I go up, down, up. All right. Beryllium. Same thing. We're just going to keep adding. 1 S2, because they all are going to start like this now. And then it's 2, S2. And goes up, down, up, down. Boron. So now boron, if we go back to the periodic table, boron, we go 1s1, 1s2, 2s1, 2s2, jump across to 2p1. And we're just going to continue on. So we have 1s2, and then 2s2, and then 2p1. Now, when you're writing this out, you do not have to change colors like I'm doing. I'm just trying to show you that N, L, and the number of electrons are there. So we have up, down, up, down, up. Again, 5 total electrons for the atomic number 5. Carbon, we're just going to keep going. 1s2, and then 2s2, and then 2p2. And so we have up, down, up, down. Now, here's where Hund's rule applies. All right? Up, up. It's not just up, down. Well, why? Well, because each of these electrons are going to go to their own orbital before they pair up. That kind of makes sense, right? Kind of like how when you come into a place, if you don't know somebody, you don't sit right next to and on top of them most of the time. Now, there are times where there's one seat left. You got to take the seat, right? Same thing. Electrons, now they don't make decisions like humans make decisions, but they're going to go to each orbital. That's Hund's rule. All right. Nitrogen. We have 1s2, 2s2, and 2p3. So again, up, down, up, down, up, up, up. Now we're half full. And you can probably guess the rest of them, right? They're all going to be 1s2, and 2s2, and 2p, but it's going to go p4, p5, p6. So a lot of arrows. Up, 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 down for oxygen. Then we got up, down, up, down, up, 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 down, down. And then finally, everybody gets an arrow. Up, 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 down, down, down. All right. Whew. There we go. There's the first 10 electron configurations. Now, I want to talk about properties. If we look at periodic table, we know that this group right here, it likes to be charge of +1 and +2, +3, plus or minus 4, -3, -2, -1, no charge. Well, is there anything with our model that predicts this behavior? All right. And so if hydrogen loses that electron, it's +1. Helium doesn't do anything. Helium stays there. Lithium likes to be +1. Beryllium likes to be +2. Those are gone. Boron likes to be +3. 1, 2, 3. Carbon can either lose all 4 of those, or it can gain 1, 2, 3, 4. Nitrogen, 1, 2, 3. Oxygen gains 1, 2. And fluorine gains 1, and neon gains 0. So valence electrons are the outermost S and P electrons. Core electrons, electrons with the noble gas, or with the noble gas configuration. Noble gas in the period above. All right, and so let's talk about this. And helium is the top noble gas. So hydrogen does not have a noble gas above helium. So hydrogen does not have any core electrons. All of period 2, even neon, has a core of helium. All of period 3 has a core of neon. All of period 4 has a core of argon. All right? That's their core. That's the innermost electrons, not responsible for any behavior. It's the valence that are responsible for behavior. So if we scroll back down here, neon has 2 core and 8 valence. So these would be the core, and the highest S&P, those 8 valence. And that's why there's no charge. This is why neon's very stable. Fluorine, 7 valence. 2 core, 7 valence. That's why fluorine must be -1, and it becomes -1. It looks just like neon. It becomes what we call isoelectronic with neon. That's the key word, isoelectronic. And if fluorine is isoelectronic with neon, it's very stable, right? Fluorine, very unstable. Fluoride, very stable. Oxygen, same thing. Oxygen has 2 core. They all have 2 core now, except for helium and hydrogen. And it has 6 valence. So we gain 2. We now have 8 valence, and we're isoelectronic with neon. Nitrogen wants to gain the 3. Carbon go either way. Boron loses and becomes isoelectronic with helium. Barium loses isoelectronic with helium. Lithium loses isoelectronic with helium. Helium is helium, and hydrogen just loses its electron. It can actually gain an electron, but it can lose it. So those are core electrons, valence electrons. That's the electrons configuration for the first 10 elements. And in the next time, we're going to go over more electron configuration. Just lots of practice, lots of what it all means, all right? But hopefully that works for you guys. Hopefully that makes sense. And until next time, we'll see you.